Hello, this is Dave Fritz with Healthy Homes Insulation. Today we're going to show you on this video a little bit about a blower door test. What the equipment looks like, how it works, how we set it up, and what it can show you about your house. Come on in. Okay, these are the components of a blower door test. I guess the first thing we should tell you is that we're not testing the door. This is a test of the entire air tightness of the house. In order to do this, we're going to take this framework, we're going to expand it and set it up in the doorway. We're going to cover it with this plastic or vinyl tarp, and then we're going to hang this fan from it. We're going to turn the fan on. We're going to blow the air out of the house. We're going to depressurize the house, and then this instrument will tell us how many cubic feet per minute pass out of the house, how many air changes per hour there are in the house, which means how many times per hour you're buying new cooled or heated air for your home. Okay, let's set it up. First thing I'm going to do is block the door open. And that's going to stay open for the remainder of the test. Now I've got to take this framework and expand it to fit the doorway perfectly. That way there's no air leaking around the framework when we do our test. Okay, now I'm going to pop it back out and put this vinyl cover on it. This is what's going to make the doorway airtight. Set that right on the bottom of the tarp, wrap it around, and Velcro it in place. I'm going to work my way up, keeping it nice and snug. And we'll pull it tight again. Now I can put it back in the doorway. Now underneath here, on each side, is a little cam. When I push it, it tightens the frame into the opening. I'm going to do that on each side. Now I've got two more cross pieces that I put in. The first one goes near the top, and that's going to hold our control module. Same process. I'm going to pull it snug, hold it, and engage the cam. And then one more at the bottom, and that's going to hold our fan. So I'm going to hang it just above the opening. Now I'm ready to hang my equipment. My control module at the top. My fan goes in the opening. So the elastic keeps it tight. And now I lift it up so it's completely suspended. Now I'm going to plug my power cord in, run power to the fan. Take my connection cables, and I'm going to hook them up to our module. Yellow hose to the yellow outlet, red to red, and just like that. On the fan body itself, power connection, data connection, yellow hose, and our red hose gets connected right up here the tubing that runs outside. See, this can take a reading from the pressure inside the house through the yellow tube to the pressure outside the house in the red tube to balance it out, to make sure that no matter what happens, wind blowing, temperature or air changes, this is going to remain steady and constant. So the next thing I have to do is I have to put some data into the machine here. I'm going to go to the settings and I need to put in the square foot area of the home. I just happen to know that this is 1,850 square feet, otherwise I'd take the time to measure it. And we have the volume, which is, you're going to do your calculator here, (1,850) times my 8-foot ceilings. So it is 14,800. That's the volume of the home in cubic feet. Now I'm going to take a baseline. What a baseline does is it's now taking a reading, the pressure on the outside and the pressure on the inside of the house, and it's balancing it out between the two. Gusts of wind come into play, just the typical barometric pressure and the reading of the house, because what we want to do is we want the machine to know how much pressure it's pushing against and how much it's pulling from, so it can remain constant. There you go, I captured it. Now we're ready to run the test, except we have to do two things. We have to make sure that all the windows and doors in the house are completely closed, sealed up and locked, and we have to make sure that the HVAC system is shut down. This is a smoke pencil. What it does is it's got a wick in it. We take it, we light it up just like a birthday candle. Let the flame get going. And then, when we blow it out, it continues to smoke like a birthday candle. This is going to show me exactly where the smoke is going in the house, where the air currents are. And if you look at it right now, with our fan turned off, nothing running, except for me talking at it, the fan, or the smoke, goes pretty much straight up in the air. There's no currents at all. We're going to show you later when we're running the fan what happens when I light the smoke pencil then. Okay, now we're going to take the fan and go back to settings, and we're going to set it to 50 pascals. Pascals is the pressure reading. The reason we use 50 pascals is that's universal. Anybody who does a blower door test in this house is going to use this pressure to run the fan. So if I do a blower door test, or Joe Schmo down the street does one, we can compare them to each other. So now the fan is engaged and it's blowing out. It's depressurizing the house. Now that I have the fan running, just standing here, I can feel a breeze coming past me. I can feel air leakage in the house coming this way. So to help me find out where exactly the house is leaking, I'm going to light my smoke pencil again. So you can see by the smoke going sideways, remember I went straight up and down before? We've got a significant airflow coming past and going out this fan. So now as I move around the house, I can see what direction that it's coming from by watching the smoke. I get away from the doorway and come into this room a little farther, and it's going more straight up and down than it was before. But it's still got some leak to it. When I come here and I see this closet is actually leaking. I close it, you can see there's airflow coming right out of the closet. So that wall behind there, or the ceiling in the closet, is a source of leak. That's not too bad. Sometimes the smoke pencil gets a little hard to see, and I switch to this machine. So there's some leaks on this door. Obviously right there it's bad. A little bit on the windows, but not too much. window sales, but I want to tell you that the drafts in your house are from the windows. In my experience, it's almost never the windows. See, the air is just coming straight past me. This part, it's coming from this doorway, and it's coming from this direction. You can see it coming right down from the attic scuttle. So I know that the entrance to my attic is a serious source of leakage. I can see I'm above doorways now and looking for leaks. Right here, I can see it moving, pulling away. It's not a doorway, there's no windows. It's just pulling right down from the attic, right along the base of that wall. Now I can check each room. This one's not too bad. The smoke is going pretty much straight up and down. The bathroom has some issues. Could be a bad vent, could be insulation around the vent, but more than likely, you can see it swirling right here. It has to do with these soffits that they like to put in these older bathrooms. They're not sealed at all. There's barely any insulation in there. I can actually feel the air pouring out of this bath setup. That's the setting of the pressure that we're at. This is the air changes per hour. In other words, that's the number of times per hour that the air is changing over in your house. So right now in this house, we're between 14 and 15 times per hour. That means on this day where it's going to be 85 degrees, I'm recooling that air 15 times an hour. That's a significant loss.
What's the ideal number you'd like to have?
When they build new houses now in code, they want them to be about 3 or 4 on an air change per hour. Most of these 1950s houses, once we have them sealed up and settled, they can be down around a 5 or a 6, somewhere in that range. We try to look at improvements. We want to get, by sealing an attic in a house like this, we want to see a 50-60% improvement, hopefully a 40% improvement, something like that, because this is such an extreme number. Now, the more extreme the number, the better we hope to get out of the result when we come in and air seal it. So we're done with our blower door test. Why did we do it? We wanted to see where the problems were in the house, how bad the air leaks were, and what we could do about them. Here's what we found. We found an extremely leaky house. We found a great deal of air coming down from the attic, at the attic hatch, and down in the hallways. We found a great deal of air coming in the soffit in the bathroom. We found a leaky basement. We found a leaky door. We found a few other things, but mostly what we found was the attic up above is in desperate need of air sealing. If we could come through and seal an attic like this, there could be some significant energy savings in this home without any question, and definitely a lot more comfort. Thanks for watching the video. I'm Dave from Healthy Homes Insulation.